Welcome to this Signal introduction. My name is Simon Gray, and I'd like to welcome you and thank you for coming along to this Signal introduction. Today I will be showing you some of the basic functionality of Signal and its display option. Once again, I have Marjorie here. She'll be helping to keep an eye on the chat and watch to see if anybody raises a hand for a request. We will be having a question and answer session at the end of the hour. Okay, Signal. Signal is a form of oscilloscope. It expects a trigger to start sampling, but that trigger could be a clock internal to the 1401. That's the data acquisition hardware that we utilize. It could also be an external pulse from a stimulator, such as a TMS device, electrical stimulators, etc. Or it could be triggered by a waveform crossing a threshold level. So the waveform would come in digitized by the 1401. We would detect when that level has been reached and use that as a zero position, perhaps, to form a sweep of data around it. Okay, when we think about a waveform crossing, this could be, say, a heel strike and a force plate. Just as many labs use Spike 2 for analysis only, just as many use Signal, and therefore we allow many different types of file to be imported. Some of those would include the ABF and DAT file types from Axon molecular devices or Heka. Okay, so let's get started with Signal itself here, and as you can see on the splash screen, I'm running Signal version 705. Now, I did attempt a little earlier to get a 705A downloaded, but it was causing me a little bit of a problem with this new machine that I've got. Some of you who attended on Tuesday might remember that the machine froze, so I've decided to go for a brand new clean machine. But while we're here, in the splash window, you'll notice that it does tell us that 705A is available for download. It gives us the serial number of the software, but also here, if a 1401 is connected, it tells us the driver type. Now, you may spot an asterisk or two next to the driver, and that would indicate that there's a newer driver available, and it would be a very good idea to go to our website and download that, preferably with the later version of Signal. Okay, right, so we have then the file pull down of Signal. If I were to attempt to go new, we see a number of different file types that Signal can handle. Now, many of these are native to Signal. I won't go through and open each one of these as new files, but I'll open them through an existing set of files that I've set up. So a data file, a sweep of data. In this case, we have 0 far to the left of the true stimulus time. So that's perhaps incorrect. And we've recently developed a script command to now offset that 0 position to this new corrected time. And we can look at that a little later if anybody needs it. The next thing to notice is that Signal is based on sweeps. So I've got basically pages of data that I'm stepping through, and I'm using page up and page down. You'll notice occasionally that the background does go grey. Now that means the frame is tagged. It's identifying it as being different from the others. So we could tag multiple frames and say, okay, I want to now average those tagged frames, or I want to average the untagged frames. So the concept of a sweep of data, 0 could be anywhere. The 0 position could be anywhere in this sweep. We will need to look at the different sampling modes later on in another section to clearly define all of those. But basically, this is an oscilloscope with a trigger position 0. Okay, other things we can do with the display here. I did show early on in the week in Spike 2 how we could change the position or amount of space each channel exists in the data document. That's just using shift and clicking between the two. We could double click. We could change the drawing style, and we could change the line thickness, so pen width there. This is more for publication purposes. If I go up to 2 point, you can see how it's thickened up now. Continuing with the idea of publication, perhaps right-clicking and customize display. In this case, something I didn't mention in the Spike 2 introduction is the idea of a grid. You can draw this grid in the background of the frame here, and that carries through all of the pages or sweeps within the file. I'll switch that off now because it doesn't have any meaning when we come to scale bars. I'm switching on scale bars for both X and Y axes. There they are. If you wish to change the width of the scale bar, we can do that here. So let's go from 0.25 to 0.5. Oops, sorry, I should have done that. Oops, I have not got that quite right. Okay, that's a bit of a failure. Okay, I'm going to step away from that for a second. It should be that we could force scale bar size to a different interval. I may have come across a small bug there. Anyway, that may be me. Okay, so scale bars. We might now want to get this out as an image using, again, right-clicking to customize display, switching off channel numbers. You see the channel number over here, number 1, that will disappear. We may want to press home or end to optimize or to zoom out to the full plus or minus 5 volt or plus or minus 10 volt range of the ADC or recording. Okay. Now, we could go further. We could set up a channel primary color. Let's go for a blue this time. And you might notice a secondary color, maybe fairly garish here, like so. Let's get that back. Channel background color, minus reading. There we go. All right, I'll reset that actually. And now we would be on to font changes, and perhaps we go to Verdana and 20 point. Now we're ready for publication, let's say. So quickly we could go to edit and copy. If we then open Microsoft Word, PowerPoint, or a publishing package, we can paste special and put down onto that other application an enhanced meta file. Okay, so a little bit of control there. Now, if we wanted to have the settings applied from this file to many others, we would look at what are called resource files. Okay, so we would save resource file for this file and then apply it individually to others with this item, apply resource file, or global resources, which means we can apply it to all files that we open from a specific folder or subfolders. Okay, I'll just quickly show you the resource file. You can say all files here. You can see next to the silent, where are we? CMS states. Right, so I need to go to details here. So we have the data file. You see it's about 1 megabyte there, and the very small file next to it, 2 kilobytes. And that holds all the information about the drawing styles, line thicknesses, what you saw last time you closed the data file, which means that when you open the data file again, as in you've left on a Friday night and you're back at work on a Monday morning, pick up that same file. As long as the resource file is there, the image, the data will appear as you left it. Right, now, if I want to revert, then I can go to standard display here. Okay, and that brings back everything to its original form, except in this case, the font. I'll just drop that back to that 11 point. Data file. So we have the grid document, script document, sequencer document, and XY document to look at yet. I don't think I really need to go into the idea of text document, of course. So let's open up a grid document. Star there. Right, we'll do a new one for that, a grid document. Okay, here we go. The grid document, as you can see, Excel-like, and we can copy and paste data into columns and rows. I find it much more useful when using a script. So a script, a program, a macro, if you like, running under Signal here, can generate measurements per frame or multiple measurements per frame, the results of which as text can be automatically pasted into these individual cells. Now that makes it much cleaner, much nicer to look at than perhaps trying to format a text file. I'll close that now and we'll go and look at the script file. Okay, and while we're here, I'll go and open a sequencer file. Right, so just laying out the screen a little more clearly here. On the left, we have a script file, and this runs at the computer within Signal. This contains functions, loops, function calls, etc., as you can see. Now that's quite different from the code you see on the right. Now this code is loaded into the 1401 when we start sampling. Now we can communicate with that code using a script, updating variables and reading variables from it. The sequencer code living inside the 1401 is all set to run at a set rate. So it doesn't speed up or slow down at any point, which means that we can be always in control of what's happening. So for example, we might read a data point, pass it to another function, another command to compare it to be above a level or below a level, and then branch on the result. Now, if we get the speed of execution just right, then we could look at every data point in turn. Okay. Now, this code for output, for generating a stimuli, etc., is rather daunting. And you'll be happy to know that we've made that a lot easier with what's called the graphical sequencer now. If I close this data file and open another, crank data, you can see that this bottom channel here looks as though it's the crank position of a bicycle, and then I see two muscle groups here, and that looks as though it's probably a hand crank. There's many measurements that the user wanted to take out of this data. They wanted to divide each one of these crank loops or cycles into the 12 hours, as it were, of the clock. Now, we could do that with what are called active cursors. Setting up an active mode for the first main cursor, cursor 0, to find, say, a rising threshold, which may be the position here. Other cursors could then fan out to the 12 positions, but we only have 10 of these vertical cursors, so that may become rather difficult if we want to measure other things as well. So instead, utilizing a script here, I'll let it run. It asks me which is the crank channel, because we can't tell necessarily from the channel titles. I give it a start time into the file, and I say, okay, so this is all written by you or I. Oops, I did that. Right. Okay. Right, so I'm going to have to go back to that. So the idea is that we divide this data up into 12 portions, and we could then go and measure the EMG activity inside those 12 hours of the cycle. Shouldn't have moved to a brand new machine, I fear. Right, so the next thing to talk about is, as some people have asked, XY views. XY views here. Now, this I actually generated in Spike 2, but it's generated in exactly the same way in Signal. So we have a window here that we could plot, we could measure to multiple channels. So here I've just got a single channel with a fit added to it. But there could be amplitudes, there could be latencies, etc., all within one window here. And when we come to copy as text, you'll find that text document here will hold the X value and the Y values for each channel. Okay. So that's that. Right, moving down the file pull down, export as. I had somebody just yesterday asking how they could delete certain frames in the file. My answer to her was simply, well, you can imagine this is an area that we make a little more difficult than others, because who would get the blame if data was deleted? So we might take this data file, and we might then say that we wish to copy or make a new file of all of the data except tagged frames. Now, for this data view, if I click on it, you can see at the bottom, we're looking at frame number 6 of 14. File, export as, test, save. Now I can select all channels from the minimum time of the file sweep to the end of the sweep, and then say all untagged frames and export. Now opening up the same file, the saved file, you should now see that there are 13 frames in this data document. Right, sorry, I did miss that. Tagging a frame. Stepping left, stepping right, page up, page down. Control T to tag. View, and you should have, right, Control T. There is a list of hotkeys in the help. And I can show you that in a short time. And perhaps it's a good point now to raise F1. F1 will take you to the help for any function. So let's choose just one. I'm going to go here to trend plot, function F1 on my keyboard, and there we have it. The help for the XY view, and often at the bottom here, you will see the script equivalent commands. Now, as I'm here and as I'm talking about that, perhaps I could do something like create a small script view. Many of you, I'm sure, haven't written a script or perhaps even programmed before. So to get going, I would advise simply script, turn recording on, file, open, test data here, perhaps make it as large as you like on the screen, and then I'm going to put all of the cursors on the screen. I'm doing that with Control 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You could also add horizontal cursors, and I'll add just one here. If I then go script and turn recording off, I have generated the exact code to repeat that same process. However, it has found this particular data file. So I would need to delete that name to make it more universal, so I can open other data files and have the same processes applied. Okay, so I don't want to save that. I'll go back there, and now view standard display. Once again, simply double-clicking the channel, home and end. Home views the whole of the y-axis range. End will zoom in. So what else have we got to talk about in the file pull down here? Okay, there's data update mode and load and save configuration. So when we get to the sampling stage, it's going to be important to be able to load and save configurations. So these are the sampling configurations. What are the ports? What are the channels that you wish to sample? What are their names? What is the sample rate across all of the channels in the recorded document? Do you have a digital marker channel, etc., etc.? So that's where we go load and save. Now, modifications made to existing data, such as if I were to rectify and smooth this information, I may then want to take measurements and then move on to the next frame. We ask through the update mode whether to discard any changes you've made, such as this rectification and smooth, or do we always save it, etc., etc. Now, if this were data to be rectified and smoothed, we may ultimately want to revert back to our raw data, and we can't do that from a rectified signal. So we tend to often just discard or ask you each time. A much better route these days to provide a rectified and smooth signal would be instead to use what's called virtual channels. Okay, now I'm coming on to this a little early because I want to talk about the data types that we can record or see within the data document. So you're obviously aware of the waveforms, and Signal is really about waveforms and a trigger point. We then have digital data, which could be coming from a separate computer delivering to us codes. Then we have other channel types of memory, much like we have in Spike 2, and virtual channels. So here, creating a new channel, as you can see it at the bottom, it's V1, and I'm going to simply do a CH1 there in the expression field, and I've got a direct copy of that data. Now, if we go to the right here, we might look at, say, spectral functions. It's spectral edge, and I'll just allow it to do its thing here and optimize. Now we're looking in the power domain. So we have two waveforms, one that's generated through an expression from the original recorded data, and of course the recorded data itself. Now the virtual channel acts just like any other waveform, so we could use active cursors on it and so on. Okay, just had a note through. Can you give a brief overview of when you would use Spike 2 versus Signal to collect and analyze data? Ooh, it all depends. Okay, if we're looking at spiking data, events, timestamps, that's really the domain of Spike 2. If we're looking at patching, as in wholesale type patching, current clamp, etc., then that's really the domain of Signal. Relatively short sweeps of data around a trigger, which could be the beginning of a stimulus waveform output for patching. This is so often used with short waveforms or short recordings for TMS, evoked response, auditory stimulation, etc. So small snapshots of data in response to a stimuli. However, the Signal program has also been used to measure vibrations. One fairly famous but not so recent application was trying to measure the vibration on our Millennium Bridge in London, which opened on the turn of the millennium only to be closed down again because as people walked across it, they were getting ill, almost seasick. So we took a couple of systems down to London, plugged it in, and we looked at the vibrations coming through the dampers, etc., and helped to improve on those. So in summary, I think short sweeps of data around a trigger, that would be signals domain. If you want to record long-term, looking at such signals as blood pressure alongside short epochs of stimulus response, then I think we're moving back to spike 2. Right, I won't go into all the print setups. We'll now have a quick look at the edit pull down. So we have looked at, I'll be there in a second. Right, we have looked at just copying as text data from the XY view. We could look now at preferences. Again, quite similar to the spike 2 setup, edit preferences there. And I think it's fair to say that there is quite a lot of code that's shared between the two programs, spike 2 and Signal. So there should be a fairly common feel. Those people who are used to spike 2 tend to be able to migrate quite easily to Signal. It's just this mentality of a page of data, and you're flipping between those pages in Signal versus this long continuous paper trace that you might have with spike 2. Anyway, here we can set up line thicknesses. Many people, they wish to see their axes, their x-axis in microseconds or milliseconds. You could set that here. Data display modes, line thicknesses, etc. And as I mentioned just the other day, in the spike 2 session, we might want to reduce the screen output resolution if you have a very large resolution screen, as some publication packages can't handle such a large image. Anyway, here there are other options to add in clamping, and we'll talk about that later. So if you're missing patch clamping capability, it's here that you would switch it on. Okay, so I'm going to make a break from that and answer a couple of these questions. So we have, is there a way to measure the area under the curve in a virtual channel using Signal? As I mentioned, the virtual channel acts just as a waveform, acts exactly like any of the recorded waveforms. We can change the sample rate of the virtual channel, however. So if I produce two cursors, put them on the screen, and I wanted to measure this burst of activity, then I could go here to cursor regions, and we could look at area, modulus, or we should have the curve area. Okay, so area is generally what people would use. The modulus treats everything as positive, and curve area is where we form a different intersection. That is, we're not using 0 anymore. So if I put cursor in the middle of this section here, and I put another cursor over here in this flat area, I would now have a 0 line intersecting those 2 points. So everything above that would be considered positive and everything below it negative. So that's a slight difference with the curve area measurement. Okay, so curve area. Right, Shi-Wen, to follow up on the last question, how to first rectify and then measure area under curve? Okay, well, you've got an idea of area under curve with two cursors just placed there on the screen. But I think we're going to have to move into the cursor's active mode fairly soon. In fact, I'm going to do that. I'm going to use virtual or our original channel here. Okay, and in fact, let's throw that one away. Let's get something that's a little little better for this purpose. Okay. Right, so you can see clearly a stimulus and you can see a response here. Now, this is silent period from a TMS experiment. So we want to measure area under curve or peak to peak in this area. Okay, so remember we could do this on a virtual channel as well. We could modify the source channel where we can rectify it, but I think I'd like to impose on you the idea that using virtual channel to rectify and smooth would be a better idea. And we will look at that in more detail in a short while. Anyway, to get measurements out, I would go here to measurements, and then we have a choice of XY view or XY view trend plot if we wanted to output data to a separate view, the one that you saw with the fit earlier. Or we could output to another data channel within the data view. However, we are limited then to time on the x-axis. So I think we're going to need XY view or trend plot here. Much of the time, you're going to need the trend plot. The difference between trend plot and XY view is that XY view can expect multiple measurements per frame, whereas a trend plot will take one measurement per frame. Let's go to trend plot here. And now we're going to plot the frame number. Okay, we know that this is frame number 7. We're shown that here. We're shown that at the bottom here, and it's frame number 7 of 18. The next thing I'm going to do is to say what is the peak to peak amplitude of channel 1, and then I can define times. Now, if I had a cursor on the screen, then that time could be cursor 1. I could also say cursor 1 plus 0.1 as a time, and specify the end of the peak-to-peak measurement as being the maximum time in the sweep, or the x-axis high point. So if I were to zoom in a little bit to 0.75, whatever the x-axis range is at the upper limit, that would be the end time. I'm going to say here 0.35, just to give a mixture. Okay, and start time 0. Let's have a look. 0.25 is actually going to give us a problem. So what I'd like to do is zoom in a little bit and choose point in between. So 0.26 looks safe. We're away from the stimulus artifact and we're good to go. So back again. I don't need this cursor anymore. I've got the times that I want. I can press new and I can process all frames in the subset. We will come back to this and describe it more clearly shortly. There we go. So now that is the peak to peak amplitude within that time range for all sweeps in this file. Okay. So hopefully that gives you an idea, Shiwen. If we go back by right-clicking the XY view channel process, and we said the curve area or area measurement, then we would obtain something similar. But that's using 2 fixed times. Let's change that just to show you that we can produce more than one output. I'm going to add another channel. This is going to be area. Change now to area and change process using the same options we had before. So area now at the bottom, peak to peak amplitude. There's more. If we go back to the process settings, we can add yet another channel. And here we have the measurements that could be taken automatically. Now these are mimicked inside of the cursor Y values, cursor X values region. But as you can see at the bottom, there's a number of frame variables. And these can be quite important These could be quite important when dealing with TMS. So frame variables here can contain or hold the intensity of the magnetic stimulator, perhaps another frame variable holding the interval between paired pulses, etc. So these values can be used to for the trend plot as well. Okay, right. If I've just seen a note, do we need to rectify it first? Well, if we did modulus, then no. It took the area as the modulus mode, then everything here would be treated as rectified. But then we probably want to smooth it. So let's go back to the duplicated channel here. You remember this was the virtual channel. So, oops, that's not. Let's go create new channel. Right, we're going to go here and we're going to say that we want to create a mathematical function. So we want, sorry, channel process function, so rectify. So that's absolute there. Okay, so there's a virtual channel. It's actually got 0 in it at the moment because the expression here needs filling out. And to do that, we go add channel 1 that we wish to process. Okay, so now we have source data rectified. Now, if we wanted to, we could add around that a smooth with a time constant as opposed to a 3 or a 5 point smooth. Okay, so we do it over a second, so that's a heavy smoothing. Okay, and we're going to put that part of the expression cut out and pasted into here. And we should now see a really smooth trace. Reducing the smoothing factor. There we go. There. So as TMS, an MEP here, it doesn't really lend itself to rectify and smooth as we would normally have with surface EMG recordings. Anyway, hopefully that gives you an idea how we might rectify and smooth the data using a virtual channel. Okay, Lara, when you have an XY plot with multiple channels, can you output the data to the grid document? Yes. So what we may do, that is, we could copy and paste it into the grid document. So let's go to the trend plot. I think we've got all our channels. Yeah, at least a couple. New and process. Okay. Edit, copy as text. New grid document. Paste. Okay. So it just keeps it a little nicer than sending it directly to a text document. Right, I'm sure that's not quite what you mean, though. You'd rather get that it is output to the grid document directly. And for that, I would use a script. Simply, as the measurements are taken, you would use the row as the frame number, and then you would increment across through the columns where you know you'd like to paste or print the output. Okay, then we have. I should really go to View and Info windows, because your question is pointing me really at this. So started in Signal and transferred over to Spike 2. I realized that this would be quite useful many years ago at the Burke Rehab Institute in New York, where we were finding that the TMS machine was a long way away from the recording computer. It was rather difficult to see what was happening at the bottom of the Signal screen. So if you see my cursor move on the data view here, there are X and Y values and channel numbers appearing in this field here. Now, rather small, you might agree. There are functions such as Control-Alt to take measurements. There's a peak-to-peak. If I drag right, you're getting a time as well as amplitude. If I drag right with no Y change, it's only direction. And same if we go vertically here, okay, for amplitude. Here, we could set up a number of things. We could set a timer reading, the current frame state. We really need to talk about that soon. Local time, etc. So a timer reading. Start on reset time, 10 seconds, count time backwards, stop at 0, apply. So a timer like this could be there, large on the screen, identifying or showing the experimenter when the next pulse is due to come, or how long has it been since the last stimuli was delivered. If I add or remove this actually and put in a frame state and apply, you'll see that this is frame state 0. Now, we can have multiple output in this window. I'm hoping that we've got a different frame state here, but we haven't. Okay, so I'll need to just open something else to show you that. So open and DMS states. Right, now info window, new window, settings, get rid of that, and frame state. That is state 2. I step through state 1, state 2, state 3, etc. So what are states? Well, we have this concept of a sweep of data that we've captured. Well, we could have used different states or a different state to generate the result that we see in that sweep of data. So imagine here we had a single pulse TMS experiment. On a second state, we might have had paired pulses. So something like another pulse generating this output. And we'd like to separate them. So we mark each sweep with the state used or the output used. Single pulse, paired pulse, whether it was a sinusoidal output for a electrically driven stimulator or stimulation, or whether it was a square wave, an identifier in terms of a numbered state. Okay. So that's the idea of states, and that'll become a little clearer in a few moments, I would hope. Let's get rid of that. So nothing more really in the edit view now. Okay, the buffer will be important to some of you, and I'll explain that, but I would like really to hold that for the analysis section. We're sticking with a little more of the display at the moment. And so just very quickly, I'm going to show you overdraw frames. Okay, so now we've decided to overdraw all frames within this file. So we've made the pages transparent, and every sweep is showing through. The current sweep, that is, we're on frame 16. So sweep 16 is the one showing up in red. Options to color cycle, set to 3D, change position. It's better do it with one channel actually. View and overdraw settings. There we go. So the idea, you can change the waterfall type display, the aspect ratio of the waterfall display. Okay, right. Just before we move on, Casman, can you display cursor region measurements there, or value calculated by code to print to info window instead of log? Peak to peak subtraction, for example. Yes. If we had an info window and we had cursor 1 on the screen here, for example, something fairly simple, we could do curly brackets, y at, open brackets, C1 on channel 1, close, and that should do it, I think. I haven't got that quite right, C1. Okay, those expressions like this, where we're saying we want the y measurement at the position of C1 on channel 1. And this should be replaced with the values that have been calculated. If we use a script, we can put it in straight from the script itself. Here in the data view, we can't do much more in the built-in functions there, but there is a lot of detail in the help about setting up those special types of measurement reports or output. Much simpler, though, to use an XY view. So if an XY view is being produced from this data, like this process, we can have an info window attached not to the data view, but to the XY view instead. So info window, create new, at which point you can see we're getting X and Y measurements out, and those settings could be set to point measure. So the latest data point on the Y coordinate. There we go, apply. Right, so 1.44. So that's the latest data point added. So if you can imagine that we're sampling data or stepping through sweeps, adding measurements as we go in a more manual form, I'll show you that as well, then this could be showing you, and in fact, it could also speak the value as and when there is a change. Okay, so I hope that answers your question there. Value calculated by code to print into info window instead of block. Yeah, I think I'm getting there. All right. Setting to standard display here, channel 1. I think I'd like to jump into the cursors now and show you a little more of what they can do. Before, I had cursor 0 set up, and that's a bit of a habit because it is essential in the Spike 2 program. It's not as essential in Signal. Cursor 0, if used here in the data file, can iterate through all of the data in this one frame, in this one sweep of data, finding features perhaps like rising thresholds, peaks, etc. So if I set this quite low, so minimum amplitude, say 0.1, okay. Now I'm using Control Shift and the right arrow. You can see I'm finding lots of peaks. Now this is actually a rise and a fall around a local maximum. So we can track peaks on a changing baseline. But there are many, many of them in this sweep. The data here shows me that I only need to concentrate on a relatively small area, and I don't need cursor 0 to iterate through the sweep of data. Before I move on, though, I'm just going to set up cursor 1 to do something very simple, and that is cursor 1 set to an expression, and that expression could be cursor 0 plus 0.05 as an example. As cursor 0 moves, cursor 1 is always 0.05 seconds, in this case, to the right of it. As cursor 0 is asked to step to find peaks, step, 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 again cursor 1 will move exactly that time interval away from it. All right. I'm going to eliminate cursor 0 mode, set that to static. Okay, it's not necessary for our data. And I'm going to cursor 0, hide. You can't delete it, but you can hide it away. Cursor 1 now, active mode in its own right. So instead of an expression, I might ask it to find data rising above a threshold on channel 1. We're looking from 0.25, let's say 0.26. And then we're looking up until the end of the file or frame. And the threshold level I'm going to set to 1. And thereafter, we can look to reject noise. So, yes, look to reject noise and a delay after crossing. That'll become important in a minute. The position if search fails. If a search can fail, such as this rising threshold, if the data didn't achieve it, we want to perhaps reposition the cursor to 0 or another time. That may then indicate in the output that there was nothing measured because the latency was 0 between 2 times, or the amplitude was 0, amplitude difference was 0 between 2 positions. We say, okay, so cursor 1 has jumped to that position as soon as I said apply. And as I step through the frames, you can see there are times when it fails and times when it finds a rising threshold. Okay, now cursor 2 could simply be asked to find a position some distance away. Cursor 1 plus 0.1. Okay, and you'll see that the pair of cursors moving around. So let's zoom in a little on this data. People want to measure the silent period here. So we're going to make things a little more interesting, and that could be to add in a cursor, horizontal cursor or 2. So here's the first, and this 2 could become active. And say to it, we want mean plus standard deviation of a factor. So we want to measure automatically from, say, 0.05 to 0.1, and we're going to have a scaling factor, standard deviation scaling factor, a multiplier of 2. So, okay, so that now would be 2 standard deviations away from the mean in this area. Add a second cursor, active mode. Once again, mean and standard deviations, the same times 0.05, and we're going to say 0.1, and this time it's minus 2 standard deviations. Okay. Cursor 1 is finding the beginning of activity. Cursor 2, we know that the silent period doesn't last so long, so we could now add cursor 3 and cursor 4 to start either in the midpoint between the 2 here, or we could set them fixed and to a fixed time, and then move out left and right from the center position here. So I'm going to ask data falling thresholds, or within and outside dual thresholds. Okay, so within dual thresholds, channel 1, we're looking to start at, say, 0.3. And we're looking to end at, well, we could say 0, because we're doing a backward search from this position backwards through the data. The threshold levels I'm going to set up, cursor 1 and cursor 2, and we can say OK. There we go. So now cursor 3 has latched itself to the intersect of the horizontal cursor with the waveform coming down there. Now that was the easy part. If now we take cursor 4, active mode, and we say outside dual thresholds, and we start again at 0.3 and head to the end of the sweep first threshold, H cursor 1, second H cursor 2, and say OK. There we go. Now, I'll zoom in again, try and make this a little larger. Now you see here, we've got the first time that the waveform has gone below or past this horizontal position. Okay, many of you, that won't be good enough because it may just be an errant data point. So we really wish to make sure that data had gone out and stayed out for a certain amount of time. So with cursor 4 here, we can set the active mode once again, but set delay after crossing. So we could say it must be outside for a millisecond or so. And there we go. That's the first time we really did leave and stay outside the threshold. Right, so now we've got those cursors set. We could use the resource files to apply the cursors to other data files that we open. But we could always go to the trend plot or the XY view if we really wanted to, or even the data channel to start plotting these out. Now we use a trend plot for the moment. Let's make sure everything's deleted here. This one is duration. And that, oops, duration. And that's simply the time difference between cursors 3 and 4. All the other cursors may just have helped us get to this position where cursor 3 and 4 are correctly identifying the beginning and end of the silent period. New and process. Now there'll be some small values and some large there. Again, we can copy and paste as text into a grid view, etc. So that's that. I'll show you what I mean by the XY view and the measure to channel as well. So the bottom half here is the trend plot, essentially. The top is identifying what you're asking cursor 0 to do, how it iterates through that sweep of data. Now this can be useful, especially when we use user check position. So I'm just going to leave that as peak find. It's meaningless at the moment, but if we go new and process all files, you'll now see that you are asked to inspect the data and accept or reject the measurement. As we add, you'll see that there's data points being added here. Yes, yes, yes. There we go. So X and Y remain the same, left over from before. We're just iterating through this sweep of data with this cursor 0. Now if I go yes to all, there's all of the peaks in all of the sweeps for that channel 1. I think we'll cancel out of that. You can. Okay, there we go. There. Funnily enough, it's looking much like a silent period area. Right, so it's found lots of peaks. Again, output as text or an image, especially enhanced metafile. Right, so where did we get to here? All right, now it's really on to the analysis, and we will be looking at that in great detail in a couple of sessions' time. So perhaps a couple of tasters then. Let's go back to, let's go the XY view. Imagine this is a waveform of some type, not necessarily the XY data. We could position cursors here, so, and we could then move on to fit data. Applies to waveforms just as it does to the XY view. Fortunately, my spelling has still gone, or caps has still gone wrong there, and set a Gaussian between cursor 1 and cursor 2 and show the fit between those two cursors and do a fit. So there we have it. Now, we've used the values of peak-to-peak amplitude, areas, etc. for the trend plots. we talked about using the frame variables, which are intensities, interstimulus intervals, etc. But we could also use the output of fits for those trend plots as well. Right. The majority of the data I've used today is my own, but anything that I've done here today can be reproduced using the data in the data folder of Signal that you have. Okay, so the question was, is sample data provided anywhere for us? If you wish to have the data that I use today, I'm happy to hand it on. So there's very much more we can go into. We're finished now, but let's just show you a little bit about the outputs and essentially the auxiliary states. Okay, so what I need to do first is set multiple frame states. And that means I can get different types of stimuli generated and output in a random protocol or other order. As soon as I apply multiple frame states, the states tab pops up. Inside the states tab, I can then say the number of extra states. So let's say there are 3. If I'm here and I'm dealing with TMS, I can go to auxiliary and I can add in multiple magnetic or electrical stimulators. So there's our own current stimulator, there's one electrical stimulator from Digitimer, the rest are TMS devices. I believe it's 10 of these that we can control simultaneously. Let's throw in a mag stim, for example. If I stim there, all the intensities can be changed per state. So state 1, looking at powers of RMT, and I want this one to be 120 for first pulse and 140 per second. And you can see how it differs from the others. And then set the interval between pulses to be 5 rather than 50, etc. So when we call or pick one of the states out of the hat to use next, then the stimulator is set to these parameters. And then we would usually trigger it using our outputs page. Where at the start we looked at a sequencer, that was a text sequencer. Now we get to see pulses, which, if we configure the pulses, you'll see the outputs that we can create graphically. I'd advise not using basic to have any states, so it can be used just as a monitoring state. But all of the others, the 3 extra states that we've added, we might want a train of digital pulses. We might want to add in a ramp and square wave, etc. So this is where we generate the pulse outputs. If on the blue line, let's do another one here. Let's just put a single pulse on the digital line. Okay, so now you can see that if I call one of these 2 states, I will get a very different type of output, and therefore hopefully a different type of response. Okay, so that's as far as I'd like to go with that at the moment, but hopefully it's given you an idea of what the states are in relationship to the sweeps that we have captured. Okay, the states are the next big step. And they'll be covered in sampling when we really get into the nitty-gritty of developing outputs and recording back in the responses. Okay, so can I ask if anybody's got any questions at this point? And we'll start winding up. I think we answered many while we were going through the session. See anything yet. Can you create a known wave from states? Okay, I'm going to have to guess a little at that. why don't we do this? Let's take test, the file we created earlier. We don't need the data in the file, but we can create a virtual channel, okay, which is not, doesn't have any relationship to the data already there. And I'm going to say to it that I want to generate a waveform. I want to generate a sinusoid of, say, 10 hertz, and that's only so we can see it. And there we go. So there's a 10 hertz sine wave. Now around that, or in addition to that, I could create an envelope. Now, if we set a rise time 0.1, 0.3, 0.4, okay, and multiply that with the sine, I'm generating in a virtual channel some sort of tone pip. Well, by the way, we are recording these sessions, so we can make that available on our website. Now we have a waveform section, a known wave, if you like, or something like our originally recorded data. Then we can take it and use it in the outputs. There we go. Control C to copy, sample, sampling configuration, outputs. Oops, I should have got multiple states there. Outputs, configure pulses, state 1. Here we've got an arbitrary waveform icon on the palette. Paste it up here, paste. There we go. Okay, so there's an arbitrary waveform added, so known waveform added. It could be square waves, ramps, sines generated from this palette too. But as you can see, if I can generate the waveform within Signal using the virtual channels for a script, or even import that same waveform from elsewhere, I can add it to the output. Is there some way to remove TMS artifact? Wow. Artifacts are a really big problem. So we could, in fact, this is a good example, what we see on the screen now. The amplifier may be hit hard by the TMS pulse, and you get this sort of ringing, and it can go on and swamp your response. And that's rather difficult to get rid of. If you simply had a large stimulus response you wanted to cut out or subdue, we could smooth it, we could use a median filter, etc., to hopefully reduce it. But with TMS, we tend to want to head towards what's called a clamp. So we have them fitted to our some of our 1902s, and that means that we signal to the amplifier, the clamping circuit, moments before the stimulus is applied, and it clamps. It effectively holds the input at a known level. The stimulus then happens. We're still holding that level, and then we release it a few moments after the stimulus has disappeared. I mean, we're talking milliseconds. And that means that we have less of a jump from input to output. So we don't have this high step to go through, which can cause problems with the filters as well. And that usually helps with stimulus artifact with TMS. But there are other methods as well. So Shiwen, please get in touch again and we'll talk about any particulars. Right. I think there's a little more I should add apart from something I should have said right at the beginning, and that is toolbars. In Signal, people tend to jump around a lot with their sampling configurations, and that means file, load configuration, find the location, open the file, etc., etc. So please, if you do find yourself doing that, both for scripts and for sampling configurations, do this. Sample bar list, add, we go to our documents, Signal 7, we might have configurations in here. We would add that file. That could have its own comment added to it. And once we've finished, we would add the script and sample bar to the screen here, at which point clicking on the buttons represented over here at the moment, clicking on each of those buttons would load immediately the configuration or script and run it or get the data ready to sample. Okay, so it's a lot faster step, especially again with TMS, where you want to move from baseline monitoring to then go to SICKI to LICKI, etc. It's a one-click process. Right, any more questions? Okay, well then, if that's DAC, what is the difference between DAC and DIC? ADC? DAC. So a DAC is a digital to analog output. So we've got a digital signal there. We generated it using the virtual channel. It's in digital form. We're going to put that through the 1401, which has a digital to analog device. So we get a waveform coming out of the 1401 to drive another device or produce a sound to the ear, for example. I'm not quite sure what DIC might. I know where you are. You're looking at the sampling configuration and configure pulses. Right. So here we have DAC, digital to analog. If I add in one of these, we have digital outputs. So when I configure, we've got dig and DAC. Okay. Digital, it's on or off. There's no amplitude that I can change on these pulses, just duration and the time of the pulses, as opposed to putting up a square wave here, which now I can say I want it at 2.5 volts in amplitude, and it has a length of, say, 0.5. Okay, does that answer your question? I hope so. Right. Good. That again will be covered later in the sampling and in even more detail when we get to the graphical sequencer. Right, a couple of useful functions just to fill up a little bit, a few seconds of time. Naming template and a file path. So you may have subjects coming through during the day, setting up a file name template. So you might give the day and month, year, etc., followed by 00 or the subject's name. So that would then automatically be saved to, with that name, saved to a folder of your choosing. You could limit the number of frames that you capture. So you've got 20 repetitions, you've got 20 stimuli delivered. You may always want to repeat a couple that may have failed and automatically save the file as a safety when you stop recording. So at the moment, when you stop and finish, the data isn't actually saved to disk fully. Okay, I think this last question is the graphical sequencer available in 604. Indeed it is. It's been around for quite a few versions now, and there are subtle changes. So in the latest version, you can edit the channel titles here. So that makes it easier to understand, well, this DAC happens to be the sound output. This dig happens to be the magnetic stimulator trigger, etc., etc. But fundamentally, what you see here, what we've done today, is all available in 6 and in version 5 as well. Okay. So let's wrap things up unless anybody has a last-minute question, and we'll get on for the next real session of sampling and get some TMS going alongside of some more interesting waveforms, and let's see some real analysis come out of that. Okay. So I'm going to call a halt to the meeting. So thank you again for coming along, and we'll see you the next time.